Everyone, let's get right into the show. We are going to be dealing with chapter 6.2. And when you look at the homework, you might be pleasantly surprised to say, oh, there's only 2 chapters this week. That's nice. Can't be too much work. That is a lot of work. Remember last time we talked about this situation here, where you took a single curve, y equals f of x, and you rotated it about the x-axis. Here's y equals f of x, and here's my little picture of what it looked like. And if you drew that shape, wouldn't it look a bit like, let me see if I can try it. I'll try it anyway. Something like that. Goes down here, something like that. It would look like a pawn in a chess set. You ever seen a pawn in the chess set? If you turned it on its side. So we're going to find the volume of that. And the formula is the integral from a to b of pi, whatever the function is, squared dx. And that's it. And here are the questions from the homework that are like number 1. We are also going to look at a single curve, but this time the curve is x equals y cubed or x equals y squared plus 1. And this single curve is going to be rotated about the y-axis. So if you imagine that's the y-axis and you've got a curve and it's rotated this way. And we're going to find the volume of those shapes. And we will get started, but won't finish, based at least on my last class, this one, which is how do you do the area between 2 curves being rotated about the x-axis. And then you've got some other associations here. So when you look at that list, you see how many different things and different situations of rotation exist. Single curves and between 2 curves, x-axis, y-axis, parallel to the x-axis, parallel to the y-axis. 6 different situations in total. And we are going to be looking at eventually how to do all of them. So far, so good. Right. So, where's my little guy? Keep this guy here. Right. And my list is going to be 1, 3, 4, 5, and 6. I won't obviously do all of them, but just take a little mental note of them. There we go. And show you the approach. This is a version of question 1 in your homework. And we're going to be taking the curve y equals log x. We're going to be doing a y equals 0. And we're going to be doing the line equals 2. And it's going to be rotated about the x-axis. So it's a single curve rotated about the x-axis. It's this guy here. So what you should do is you should sketch a shape of the thing. And the reason why you should sketch a shape of the thing is that sometimes you think it's a single curve and it actually ends up being the area between 2 curves. Secondly, you have to know where to start and where to finish, right? You have to know the A and the B, and that isn't always as obvious as it looks, especially from the information that you're given. So I want you to imagine I went into Desmos, and that's what the natural log of x would look like. I'm pretty comfortable about the shape. That's log x. Now, x equals 2 is about here. And y equals 0 is just another name for the x-axis. So the region that we are going to be rotating is that region there. And it's going to get rotated about the x-axis. Now, once I've got a picture in front of me, I can then start filling in the blanks here. The volume. Oh, here's my first problem. Don't I need to know that number? If it was Desmos in here, wouldn't I just click on it and it would tell me the number? But since Desmos isn't here, you should be able to tell me what the x value at this point here is. What number is
it? Isn't it 1?
Correct. Isn't that the x-intercept of the log function, and the log of 1 is 0? So it's going to be the integral from 1 to 2 pi. The function is the easy part, squared dx. And in fact, that's all you're being asked to do in question 1. They don't ask you to find the integral, just to set it up. So that makes that question really quick, doesn't it? You're finished. Now, we go on to the next question in my list, which is question number 3, or at least one like it. Let's see what they do this time. It's a straight line, in my case, y equals x plus 1. It's y equals 0. It's x equals 0. And it's x equals 5. And it's about the x-axis. Again, I would, well, maybe I don't need Desmos, but pretend I did. I would do it in Desmos. And y equals x plus 1 essentially looks like that line. Y equals 0 is the x-axis. X equals 0 is this axis, and x equals 5 is here. Are you comfortable about the region? How it came about? Straight line, x0, x5, y0. That's the fella that you're going to rotate about the x-axis. So its volume is going to be the integral from 0 to 5. Pi f of x, which is this guy, squared dx. And I'd pull out the pi, and I'd FOIL this out. And then I would do the power rule. And I'd evaluate it at 0 to x equals 5. If you plug in 5, you get 1/3 times 125 plus 5 squared plus 5. Take away a whole lot of nothings. So that's 125 thirds. Well, 30, which is 90 thirds. 90 plus 125 is 215 thirds. So, okay, I could do that in my head. There's your answer. The volume of that shape would be 215 thirds pi. Now, if you imagine the other half of it down here, this thing would look like you took a cone and cut off that bit there. Imagine what that would look like. Imagine you took a cone and just cut off the head, and you're finding the volume of the back bit, which would be essentially that guy there. See how we can find the volume of all sorts of weird shapes using this technique. Any questions about that? Or we feel good? Okay, move on. Question 4. That's square root. Y equals 0, which is essentially the x-axis. X equals 7. I'm going to do it about, again, the x-axis. If you go to Desmos and draw the square root of x minus 1, you get that. That guy happens to be 1. Let's say x equals 7 is here. Y equals 0 is that guy there. That's the fella that we're going to be rotating about the x-axis. So we've got everything in that picture that we need. We just fill in the blanks. It's going to be the integral from 1 to 7 pi, the function squared. Pull out the pi and square that guy. Oh, that's easy. And at this point, I'm just going to do my dot, dot, dot. would you be happy in finishing that off in the usual way? It's got a flow to it, doesn't it? Information becomes picture. The reason we need the picture is, don't we need to know start and finish numbers? Plus we need to make sure that it truly is just one region being rotated. And then plug in the, fill in the blanks and then do a bit of algebra. Any problems with that? Are we good? The next one in that list would have been question 5, but I'm skipping by it. And we'll move on to the last one of this type, which is question 6. And it's y equals e to the x, y equals 0, x equals -2, x equals +2, and it's going to be about the x-axis. So this is the last example of a single curve being rotated about the x-axis. And again, if you do it on Desmos, that's what that fellow looks like. There's -2, there's +2, there's y equals 0. You see it's a single region, a single curve, that curve, being rotated about the x-axis. So it's going to be the integral from -2 to 2. Okay, I can handle that. Pi, the function, squared dx. Pull out the pi. Okay, a little bit of algebra. What is e to the x squared? What single power of e is e to the power of x squared?
E to the 2x.
Correct. Do you know what the most common mistake that people think that is? They think it's e to the power of x squared, don't they? It's not. Isn't e to the x times itself e to the 2x? Right, now we have a very minor hiccup in integration. We're being asked to integrate e to the 2x. I would see that as a substitution. Not the biggest, weirdest substitution in the world, but isn't it e to the ugly guy, so the ugly guy is your u sub. What makes you an ugly guy? If you ain't an x, you're an ugly guy. So wouldn't e to the 4x and e to the x plus 7 and all sorts of other e to the x stuff also count as u subs? Now for this very simple substitution, when you differentiate it with respect to x, you get 2. When you do the crossover and then divide both sides by 2 to isolate the dx. So the volume of the shape is going to be pi. The integral of e to the 2 thingy becomes e to the u. The dx becomes 1/2 du. Are you happy about this integral becomes that integral? Okay, seeing nods. And that's going to become pi. Integrate that guy, it's just this fella. And if you return it back to its original, you can then evaluate it at -2 and at 2. So that was the original. We did some substitution, turned it into that. We integrated it and got that. We replaced the u by 2x, and now we're here. Have you noticed that in these two middle lines, the -2 and 2 have disappeared? I don't write them down. And this is maybe pernickety, but it's good math. Why didn't I put a -2 to 2 here, or a -2 to 2 even here? Why did I not write those down?
Because this is integral e to the u, not e to the x, and so the parameters are different.
Correct. That's the reason. So just don't write them down until you get back to the x's, and that's the safest thing to do. Now, if you did want to use them, wouldn't you have to do -44? I mean, if you felt like it. Right, this fella here then is pi. If you plug in 2, you get half e to the 1. Take away, if you plug in -1, you take away a half e to the -1. I would probably, for style points, pull out a half and rewrite the thing like that. Are you comfortable with the kind of style point version of the answer? Plug in the x's, pull out a half as a common factor. E to the 1 is just e, and e to the -1 is just 1 over e. Just looks nicer.
Wait, on this one, would it be, is it e to the 1 or e to the 4 when you plug in the values?
Oh, yes. Well caught. Did you all catch that deliberate mistake? You know I'm lying when I said that's a deliberate mistake. That was just a mistake. Yeah. I made the mistake. Are we good now? Okay. Well caught. I like it when people do that, because what they're telling me is that they know the process. Okay. Let's move on to another situation now. We have done single curves rotated about the x-axis. Let's do single curves rotated about the y-axis. And I'll hide that one for a minute. Show you what it might look like. Imagine you have a curve, what would we call it? There we go. And this curve is called x equals f of y, right? And you're going to rotate it about the y-axis. And it's going to start life here at C. And it's going to finish, say, here at D. So the guy that's going to be rotated about the y-axis is this region. So you can imagine it's going to rotate that way. Now, I'm going to take I'm going to try. I don't think I'll succeed, but I'm going to try. It would look to my eyes like a solid vase. Can you imagine the shape it would look like, right? If you rotate it in the y-axis, you see? Now, we need a formula, just like we did before for rotating about the x-axis. Now, a lot of math has patterns and symmetry to them. So when you know the answer to one situation, you can very often use that answer to help us with a different situation. So, no, that's not the one I want. Here is the one when you rotate something about the x-axis. Here is the formula that generates it. Could someone try and create, using that as your framework, what this formula might look like? Look for patterns, look for symmetry.
Wouldn't it be the same except it would be f of y and dy?
And yes, it would be. What would these limits of integration be called? They won't be called A and B.
Would it be just C and D to kind of keep it going?
The reason I like to choose two different letters is just to try and emphasize these are X's and these are Y's, right? I think it just helps. It's cosmetic. You could call them anything you like, couldn't you? Start number, finish number, if you wanted to use words. Now, when you see that set up, would you agree that it's remarkably similar? Great. So we should be able to do that guy for questions 2, 7, and 8. So put low. So I'll zoom back to question 2 and let's see what the information is. It's kind of the same information all the time. There's a function that you're going to rotate. In this case, it's going to be 7 take away y. There's 2 lines, y equals 0, x equals 0. But the key here is it's about the y-axis. So that tells me it's rotating. I think you could probably figure it out from here as well, couldn't you? That it's a little bit different from the earlier questions. So you would probably want to go to Desmos and put this information in and see what the guy looks like. Great. So I am going to hopefully, right, show you that working. Desmos is really helpful when you're doing functions like this. When it's y equals x cubed, can't you all figure it out yourself without going near a calculator or Desmos? But when it's one of these x equals things, things get orientated in strange directions. So up here, x equals the square root of 7 take away 1. Okay. And then I just have a y equals 0, which I already know that is the x-axis, and x equals 0 is the y-axis. X equals 0 is the y-axis. Okay. So if I shrink this down a little bit, the guy that they're talking about is this region in here. Do you see it? And it's going to be rotated about the y-axis. So I'm doing a very quick copy of what I'm looking at here. It looks like that. Can't see me doing it this right now, but you will see in a minute. And it's going to be rotated about the y-axis, and I'm shading it in. Before I leave, shouldn't I pick some numbers up? Shouldn't I know that this number here, because this is the x-axis cut and this is the y-axis cut, it's 0 to 7. You happy where I got the 0 and 7 from? So I'm now writing them down in my little diagram, 0 and 7. So when I come out of Desmos, and that's basically all Desmos has done, is to give me a visual clue to the shape. Looking good? Now, rotating that guy, I mean, if you did rotate that about the y-axis, wouldn't it be a pretty boring shape that looks like that? Look like an acorn or a bullet. How about a bullet? Looks a bit like a bullet. Right, set up the integration. 0 to 7 pi the square root of 7 take away y all squared dy. And I believe for that question, that's all you were asked to do. Yeah. So in question 2, that's the end of the question. We could take that. Can we go all the way to the end and get an answer? But they don't want it, so we'll not bother. Next one in the list is question 7. Let's see what that guy looks like. Takes a while to get there, but I will. In question 7, x equals 6, the square root of 3y, at least my version is. X equals 0, y equals 3, and we're going to rotate it about the y axis. So my first stage is to see visually what the region looks like so that I can set up my integral correctly. So get rid of these guys and put in what am I putting in? Square root 6 times the square root of 3y. And then, and of course, I forgot to put in my x equals. Put x equals 0, which is the y-axis, which is basically that purple line. And lastly, put y equals 3 in. And so the region that we are rotating about the y-axis is this region in here. See it? Right. There we go. See this region in here. So I'm doing a pretty basic sketch of the same information. So if you bear with me for a few minutes while I try and draw my sketch of what that would look like. Okay, I think I'm ready. And so we'll return to the whiteboard. And here we are. That was the shape. Right, if you imagine that being rotated about the y-axis, wouldn't it look like a solid soup bowl or something? So we're going to find the volume of that. It's going to be from 0 to 3 pi, the function squared dy. I like to pull out pi. Okay, danger, Will Robinson, danger. 6 square root of 3y squared. Be very careful. What is 6 square root of 3y squared equal to?
36 3y. Square root of 3y.
Okay, 36 times 3y, which is what, 108y? Great.
The square root's still square root.
Okay, let's show you what's going on then, because I think I've heard the correct answer, although I didn't hear the final version of the correct answer. I did hear. Right, 6 times 6 gets you 36, and that guy times that guy gives me 3y. So I heard 36 3y's, but isn't the 36 times 3 multipliable, if there is such a word? And that gets you 108y. Are we comfortable about where the 108y came from now? Okay. Now, I won't take this really much further, but if you add 1 to the power and divide by the new power, you get that guy. And can we just dot that? Can you finish it off yourself? Why don't mussels buy people presents? Because
Why?
of, oh, thank you. Because
Sorry.
they're shellfish. Because they are shellfish. Kira gets it. Is that it? One person thinks that's funny. I don't know why I do this. Almost be a sadist or masochist or something. Right. Okay, I'm going to show you another one. You lot, get your brains on this one. Did you hear about the insomniac, dyslexic, atheist. No? They stayed up all night wondering if there was a dog.
Okay, that one's good. I like that one.
Caitlin? So? Okay. Can't win them all. Right. You know, I've totally distracted everyone from the storyline now. So let's get back into our job. And our job is, and it's a fun job to do, I enjoy it, is to find volumes of revolution. So the last one that we're going to deal with is question 8. Have you noticed you don't get an awful lot of practice at that? But thankfully, WebAssign varies the questions, so you'll get your own version of what I just did. So it's not like you can't actually get some practice. So we're taking that guy, this piece, and this piece, and it's going to be rotated about the y-axis, the last y-axis question. Now, I could do this fella and do Desmos, and if I had time, I would. I'm going to change this equation. And the reason I'm going to change it is quite vital. It's not just to make it easy to sketch, because WebAssign could probably sketch, Desmos could probably sketch that guy. No, it's not for that reason. Why am I calling this guy 1/3 y squared instead of just leaving it as y squared?
So you can isolate the x.
When we use our formula, don't we need an f of y? And if I did this version, isn't there a chance that you might mistakenly put y squared when you really need to put 1/3 y squared? You see, that's my reason. So when you do the formula, it's the integral from c to d pi f of y squared dy. But when you write f of y, it's implied that the formula is x equals f of y, not 3x equals f of y, or 10x, or x plus 1, or anything else. That's the main reason. Now, if we put in the other pieces of the puzzle, it goes up this way, and it cuts off that way at 5. So the guy that we're going to rotate about the y-axis is this shape. And so it's going to be the integral from 0 to 5 of pi, this fella, squared. Pull out the pi. If you square that, I think that's pretty easy to square. Can we just dot that one now? You can finish that in your own time. Feel comfortable about that question now? Just in case in the future, other places, other times, suppose you had x plus y squared, that'd be a bad choice. Suppose you had x minus y squared equals 1. Suppose you had that guy. And you were going to rotate it about the y-axis. That would not be the form that you would use. Wouldn't you convert it into that guy? A sneakier one. Start again. Suppose this shape was going to be rotated about the y-axis. Now, if it was going to be rotated about the x-axis, wouldn't that make perfect sense for rotating about the x-axis? But if you wanted to rotate this shape about the y-axis, doesn't your formula have to be x equals something with a y in it? And this guy doesn't even look vaguely close to that. So this is what you would do. Add y to both sides. And then do that. So if you know you're rotating about the y-axis, will you make sure that your formulas are x equals function of y? And if you know you're rotating about the x-axis, then do it this way. Little side issue, but, you know, just in case it pops up. So we have now finished that guy. Let's get started on this one. The area between two curves rotated about the x-axis. So we're back to rotating about the x-axis again. So we've got this fella gonna. And I'm going to have two curves. And the first curve is the red one. It's going to be called y equals f of x. And the second one's going to be green, and it's going to be y equals g of x. And it's going to start at x equals a, and it's going to finish at x equals b. So the region that's going to be rotated is that region. Now, can you imagine what would happen if that thing was rotated? I am not going to draw that thing because that wouldn't even look vaguely right. Wouldn't it look like a solid shape with a funny curved hole in the middle? We can find the volume of weirder shapes in that, but that's pretty weird. So we need to have a formula that is going to generate it. And we already have a kind, oops, hope you didn't see the answer there. What this fella is going to look like. Would you agree that it's probably going to go from A to B, just based on symmetry? Would you agree it's probably going to have a pi in it? And it's going to finish with a dx. Now, if it was a single curve, wouldn't it be f of x squared? But we're doing the difference between two, right? Any ideas of just a guess what the formula might look like that could make that happen? Don't care if you get it wrong, you have a shot at it. What do you think it might be?
X minus g of x.
Some subtracted, makes sense. Would you want some squares in the answer? Yeah, okay. That means there's two choices. And this is the one that works. Do you notice that you square them first before you subtract them? So I'm going to try and give you a proof of why this formula is the right one, why it works. So I want you to imagine that I did this shape, and I'm not even going to try and draw it, but can you imagine the whole shape was rotated and we cut it this way, right? And we looked at the picture from that direction. If we did that, wouldn't you get a shape that would look something like this? Because I'll try my best, man. As I say, I'm not good at this. Can you trust me? It would be a donut. That's what we call that. It's also called a torus, right? So can you imagine one slice of that? Imagine they had the solid shape and it was wood, and you sawed a little bit in the middle. Wouldn't it look like a coaster, right? With a hole in the middle, right? Let's see how they get the volume of that shape, right? Isn't it basically a little radius and a big radius, right? And wouldn't you find the volume of the cylinder that's the big cylinder, and then you take away the little cylinder? So the volume would be pi r squared for the big one, take away pi r squared for the little one. And the big one would be f of x. Pi f of x squared, oops, with a little delta x on it, take away pi, g of x squared with a little delta x in it. If you pull out the pi, you get the f of x squared, take away the g of x squared, and then you stick a delta x. Do you see the formula comes out? If you split that apart, maybe another way of looking at that, see if I split this formula apart into two integrals. It would be this guy. Take away this guy. Agreed that this and this are the same thing, right? Wouldn't this be the whole shape? Take away the whole. Does that convince you a little bit differently? Different ways of looking at it. Can you, third version, trust me, I'm a mathematician, it works, right? That's the third version, right? So when we see you tomorrow, we are going to be doing this fella.